Now we are going to use generating functions for counting problems with constraints, right? So let's consider the following problem. In how many ways can we fill a bag with exactly n fruits using 4 different types of fruits: apples, bananas, oranges, and pears? And we have the following constraints. So we need that the number of apples has to be even, the number of bananas has to be a multiple of 5, you can have at most 4 oranges, and you can have at most 1 pear. So this is still going to be a problem about solving an equation. So you can write it as the number of apples plus the number of bananas plus oranges plus pears has to be equal to n, but subject to all these constraints here, and some of them might look a little bit complicated. And what we're going to see is that generating functions are going to be a very good way of dealing with this. So the first step, we are going to encode each constraint with a generating function. So let's take, for example, the apples. We're going to have a generating function for this. So each apple is even. So what we mean for that, so we are allowed to choose an even number of apples. So the apple factor is going to be this polynomial here, squared plus x4 plus x6, and so on. So the idea is that this infinite polynomial, when we multiply with other stuff, is going to represent getting an even amount. So it's going to be all the powers that are even. So here this is x to the 0. So of course 0 apples would be even, so we're including the 1 here. And so a choice of a number of even apples is going to be one of these even powers here. If we want the number of bananas to be a multiple of 5, so similarly we're going to have this term for that. So 1 plus x to the 5 plus x to the 10 plus x to the 15, and so on. If you want there to be at most 4 oranges, that means that the oranges will have this term here, just 1 plus x squared plus x cubed plus x to the power 4. So here we're saying that you can have 0 oranges, 1 orange, 2 oranges, 3 oranges, or 4 oranges. And at most 1 pear would be this p of x equal to 1 plus x here. And so the idea now is that we multiply all of these together. So we're interested in the following function. We're interested in the product of all of these a of x times b of x times o of x times p of x. And so when we multiply all of these together, this will give us some polynomial, right? Some f of 0 plus f of 1 x to the 1 plus f2 x squared, and so on. And what we are interested in is what is f of n, right? So we choose one term from each factor, and this corresponds to choosing one of each fruit, like how many of each fruit, and that corresponds to choosing one term in each factor, right? And then the exponents add up, so the total exponent is the total number of fruits, and we want to know in how many ways we can achieve n, which is essentially just going to be the coefficient of the term with degree n in this polynomial here when we multiply all of these and open them up. Now, of course, dealing with these infinite polynomials can be a bit complicated, and so what we're going to use is we're going to use these geometric series that we talked about before. So the finite geometric series has this formula, right? If you do a plus ax plus x squared up to a finite amount, you get this formula. And the infinite geometric series, which you can actually obtain it by just taking the limit here for n going to infinity. The infinite geometric series, you get this formula here. And so the stuff that we wrote before, so this was our apples, our a of x, was equal to this here. So remember, the amount of apples was even, so it was this infinite geometric series with the even, so it's with ratio x squared, and so if you go and just replace in the formula, it gives you this. The bananas, which were multiples of 5, again, it's going to be a geometric series with ratio x5, so if you replace it in the formula from the previous slide, this infinite power series is just this expression here. Oranges at most 4 is going to be a finite geometric sum, so you can write it in this way, and the pairs you can just leave it in this way. And again, what we're interested in is multiplying all of these. So now we can multiply them, and so our f of x is going to be 1 over 1 minus x squared times 1 over 1 minus x to the 5 times 1 over 1 minus x to the 5 divided by 1 minus x, and then times 1 plus x. And so these, now you can cancel some of these out, right? And what you'll get is 1 over, and so also this 1 minus x squared, this is a difference of squares, so you can write this as 1 plus x, 1 minus x, so that's the first term. The second one there you cancel out, and so you get this 1 plus x divided by 1 minus x. Now these cancel out, and that means that you just end up with 1 minus x squared. So that means our f of x is going to be this function, and we are interested in what is fn, so the nth coefficient. So remember, f of x equal to 1 over 1 minus x squared. 1 minus x, all of it squared. This, you can write it as some power series, some infinite polynomial, x plus f2 x squared, and we are interested in what is f of n that we obtained there. But now, for a closed form solution, so this is quite simple. So we found that our f of x is equal to 1 over 1 minus x squared. But in a previous video, so in previous video, actually in two previous videos, because we showed it in two different ways, in previous video, we actually showed that 1 over 1 minus x squared was equal to this here, n equal to 0 to infinity, n plus 1, x to the n. So we showed this in two previous videos. We showed it actually by doing convolution, and then there's another video where we showed it by taking the derivative of a generating function. So you can go and take a look at that. But essentially we showed that this function here can be written like this. And so that means that our term fn, the coefficient, so our term fn, which is the coefficient of x to the n, is just going to be n plus 1. And so this is the answer to our question. So in how many ways can we fill a bag with exactly n fruits satisfying all these constraints here is going to be quite simple in this case. It's not always that simple, but in this case it'll be simple. It'll be n plus 1. So if you asked, in how many ways can you do 100 fruits, it'll be actually 101 ways.